presentation, which is by Meenu, who only recently came back from parental leave and is only working 50% at the moment.
Right.
But I still think it is really nice to have you back with us and talking a little bit about what your research is about right now. So Meenu, the floor is yours. The clicker is here. Yeah?
Thank you. First of all, hi everyone, good afternoon. I am Meenu. I am a PhD student from Malmö University and I am supervised by Helena and Ian. Today I am going to present my research so far and my future research. So the title of the topic is Monitoring MLDL Models in Production. So as I mentioned, first I am going to talk about my research so far and my future research plans. So as you all know, all companies with the introduction of machine learning and deep learning models, they are trying to implement or incorporate all these technological innovations to their electronics and software. As a result, the end-to-end process of developing, deploying and evolving MLDL models, they become quite challenging. It doesn't care whether you belongs to an automotive industry or telecom industry or security or healthcare industry, but everybody experience the challenges regarding the end-to-end process of developing, deploying and evolving machine learning, deep learning models. As you can see the Google paper, machine learning code, it's a very small part and you have all kinds of complexities already existing. And my research objective, and whenever you ask practitioners or experts in the company, how do you develop, deploy or operationalize models, most of them will be having, we try our ways, this is what we do, we used to do this. Most of the time when I started my research, they never had a process kind or a defined answer. So we focused on establishing some systematic and structured design methods and processes for the end-to-end process of developing, deploying and successfully evolving machine learning, deep learning models. So what we are trying to make, so we are aiming to make not only expert data scientists do all the machine learning and deep learning stuff, but also less experienced one as well as non-experts do the same job in a professional manner. So how I am going to address all these kinds of issues? So in order to address this, we conducted some studies so far. They are end-to-end process of developing machine learning and deep learning models, and we focused more on how to deploy models, whether you should deploy the models either at the edge or at the cloud, or you should go for a combination of both kind of, and what can be kind of, if you give more importance to device cost, whether you should take your model to the cloud or whether you should deploy at the edge, kind of some architectural decisions, and how you can operationalize your model once you finish optimizing your model, kind of, and how once you have a model that is in production, how you can continuously deliver values and how you can evolve this. For this we look into the concept of MLOps, that is machine learning operations. So in order to address and to cover all these studies, we focused on 3 research questions in the very beginning. They are, what are the activities performed and different challenges faced by practitioners when they develop the system, what are the different architectural choices selected by them, and how they ensure continuous delivery and evolution of machine learning and deep learning models, how they utilize the MLOps practices, kind of. So I'm quickly going to take you through all my findings. So in the very beginning of the research, as I mentioned, when we asked the practitioners in company, how do you develop machine learning or deep learning models, they never had a defined answer. So we thought that we will try to come up with some process where they should follow so that they can come up with a high performing machine learning and deep learning models. So the activities, they were business case specification, data exploration, feature engineering, experimentation, development, deployment, and operational phase. And we also studied different challenges associated with this phase and some events, so that if you have some kind of problem, if you trigger from one particular phase to another particular phase, maybe kind of if you figured out once you have some features and you figured out one of the feature is not working fine, or you just need to go and change the feature, or kind of, or you need to, once you have a very good model up in the production and you figured out that there is some data drift, or kind of, you need to come back all the way from deployment to the data exploration phase, and you just correct it and you just deploy the model, so that you can make some small fixes and make sure that you have a high performing model in production. That you can see here. Then as we all know, the main problem is, even though you have a machine learning or deep learning model in your hand, you will come to know whether it has positive business value or negative business value once it is deployed. So everything is business minded. So we just came up with a framework where it's called AI driven business development, where we included all phases that are running parallel, which you have to look through while developing, deploying, and operationalizing models, and what are the different roles associated with this, and where you need collaboration, where you need to take an iteration, and all these things. And then, as I mentioned, with one of the software center company, we did an on-site research, and we figured out 5 alternative approaches for deploying models, whether on the cloud or edge, ranging from centralized approach to decentralized approach. And here, as I already mentioned, if you maybe you have lots of opportunities to deploy your model either at the cloud or at the edge. But if you have to prioritize some factors, if you are looking for more device cost or less device cost, or if you look for more global model performance or local model performance, which particular factor you are prioritizing, we just tried to figure out which particular architectural alternative suits you best, whether the centralized one, decentralized one, or a mix of decentralized and centralized one. Then once you have developed a particular model, as you all know, most of the AI companies, even though they are developing a lot of machine learning and deep learning models, only very few models cross across the deployment phase. So we tried to figure out what can be the end-to-end deployment process, where we figured out 5 different phases and sub-activities for each phases. That you can see, the phases are design, integration, deployment, operation, and evolution. Then here, in order to ensure continuous delivery, the companies are trying to adopt MLOps in their working system. So how we can adopt MLOps to get a mature model kind of, we look into this particular research, and we came up with 3 pipelines: data pipeline, modeling pipeline, and release pipeline. And you can see different activities related to each pipelines, and where you are storing your data, like data repository, kind of code repository, so that you can have different versioning of models and all those things. In the right side, you can see where different companies are placed based on their journey from manual to fully adopted MLOps. And during our research, we figured out what are the different challenges practitioners are facing. So you can see different challenges faced by them during the data exploration, business case specification, development, deployment, operationalization. So till that slide, that was what I did till this so far. So now I would like to take you all to my future research. It is monitoring MLDL models. Suppose you have a model which you developed for a long, and you just put it into production. Congratulations, you just put the model into production, but that is just the beginning of the journey. Deployment is not the final step. You have a lot more to go. Why? Because here in this particular slide, you can see 2 pictures. Mostly in case of traditional software application, after rigorous testing and validation, once you have a code in production, it always works as expected. But it is not the case of machine learning and deep learning model. And the model, the machine learning or deep learning model, it is very good before deploying it to production. So you can expect maximum business value, like positive business value. But when time passes, the model performance degrades, and due to the customer behavior changes and all other factors, maybe you will end up in a negative business value, but that is not expected, like we do not want that. So and as I already mentioned, companies can realize whether a particular model produces benefit or like profit for them once it is deployed in the production, and we need to make sure that once a model is deployed in the production, it produces the results as expected. So to track the performance of machine learning and deep learning models in production, and to make sure that all the business objectives are met, model monitoring is a key step. Even though there are a lot of lessons and approaches are existing for traditional software monitoring, it is not the case with the machine learning and deep learning model. It presents unique challenges, so it demands use of specialized techniques, processes and tools. So in order to address all these, we propose to conduct in-depth studies focusing on the specific of monitoring models after they have been operationalized in the embedded system. So in order to address this, we have a main research question and some sub questions. So once you have a model that is operationalized, how do you monitor the model to ensure that it performs well? So it's like in the case of software code, maybe it's the DevOps team which take care of the model once it is operationalized, but that cannot be the case of machine learning or deep learning model. Maybe we need to share the responsibility. Maybe only the ops team cannot handle that particular responsibility, maybe the data scientists or engineers. It's a shared responsibility. And also when we try to monitor model, we should have an idea like what we should monitor, what we should log, what to monitor, what not to monitor, what can be the different situations where you need to monitor models, and based on that you need to take some actions. Maybe you need to deploy, first you need to deploy model, then maybe based on the performance degrades you need to redeploy model, or you need to retrain the model, you need to update the model, everything. So in order to have an overall idea of model monitoring, we are planning to look into what are the related activities and challenges that practitioners experience when they try to monitor MLDL models, and what can be the potential solutions for these challenges. And the second one is like how you can compare a new version of the model against the in production version. And the another one is how to build an infrastructure around the model for monitoring to make sure it performs well once it is operational. It can be kind of a part of model management monitoring kind of. And maybe the last one is like you have a lot of different clients in the field, and when you have a model and when you deploy the model to the different clients in the model, maybe there can be a scenario like maybe even though the clients they share similar characteristics, maybe one client they are getting good results, maybe the client sharing the same characteristic they are getting bad results. So how to identify those subgroups of clients that underperform, and how to make sure that they are they are back in performance kind of. So these are the research questions and sub questions. So I have already sent out some research proposals to company experts, but if you haven't looked into, get a time to look into it, or if you are seeing it for the first time, I would like to invite your interest. So if you are interested in taking part of the study, the monitoring of machine learning and deep learning model and all those surrounding perspectives, we propose to do action research, so that if possible we can work in close collaboration with the experts in the company, or some case study research which and both of them include some interviews, workshops, focus groups and validation study and everything. Yeah, thank you. That's it.